Welcome to Java EE6 webinar series from JPassion.com. Today we are going to cover second part of JPA 2.0 features. I assume most of you have some JPA knowledge. In fact, this Java EE6 course assumes you have Java EE knowledge on, for example, Servlet, JPA, EJB, and things like that. All right, so let's get with the presentation. So we're going to focus on two major topics in this presentation. One is criteria API, and the other one is locking. On criteria API, we are going to cover three different subtopics. Very simple criteria API using just single entity, and then we are going to see how we can use criteria API using relationship, actually, with the related tables and entities. And then we are going to see how we are going to use what is called the meta model. And then for locking, we are going to look into optimistic locking and pessimistic locking. So let's start with criteria API with a single entity. So criteria API has been very popular for Hibernate developers because it allows you to create a query using Java code rather than string-based JPQL. So you can write every query in Java code, and so that is provides a convenience. For example, in Hibernate, you can create an object, Java object that represent the query, the string basically. So it's actually to complement JPQL in JPA, and unlike Hibernate, however, JPA 2.0 also provides extra features called the meta model. So meta model actually provides compile time type checking using generics. So every entity X will have a corresponding meta model class called X and underscore. And then you can actually use the criteria API on these meta model classes. We'll see examples of that moving forward. So let's see an example. Here we are going to perform. So this is JPQL based query operation. So here you are going to select E from employee E, meaning you want to get all the records from employee table. Now, instead of using JPQL like this, you can use criteria API. So first, you're going to get criteria builder object from entity manager. And then you're going to create criteria query object. In this case, you're going to use employee generics type. And then you're going to specify kind of table, which table that you want to actually use as a starting point. So you're going to call from method, providing employee class, and you get the root object. And then you're going to call criteria.select, passing this employee object. And then you are going to then you are going to create the query, passing the criteria, and then you're going to call get result list. And then this method will perform query operation, and then you get the results back. This is where you can use where method. So you can certainly create criteria object using where method as well. So here we like to make sure we would like to have where clause sort of where the name is Sang Shin here. Okay. And you can also use order by. So criteria.order by, and then here the name, the order is based on name, ascending order, and you can also specify descending order on salary. So basically, the point of criteria API is using Java API for performing JPQL-like query operation. All right, so let's start our first exercise on criteria API. So we are going to take a look at the where clause-based criteria API application. It's assumed that you are already started, you have already started Java DB, and we are again using testDB JPA2 database. So we have already started testDB JPA2. And from that point on, you can use either NetBeans or Eclipse because all projects are Maven project. Okay, so I'm right now running NetBeans. Later on, I'm going to actually run it in Eclipse as well. All right, so I am going to go to project here. And the first project I like to try is criteria where. Okay, so let's run this application. And it's very simple. Well, actually, we'll take a look at the code. It's basically performing various, this is the set of table. This is a table, the employee table that we are going to actually use for performing various query operations. Okay, so we'll take a look at the code using lab documentation. So these are the results we just have seen. So this is a case. So here we are going to again criteria. Yeah. So here basically the documentation shows you this is how you're going to perform JPQL operations. So here you're going to create the string object that contains a select statement and then perform JPQL. And now you are going to perform the same thing of this using criteria API. So examples basically show JPQL example and then criteria example. Okay, so the red colored version is the criteria based example. So here again we create the criteria builder object, and then we create the criteria query object, and then we get the root object, and then build the criteria, and then we perform first of all, we have to create the query object here. So it's actually typed query. So you can actually have this single line with these two lines. Okay. So it creates the typed query object, and then it calls the get result list method, and then you get the result set. Okay. And then we just display it. So this is the very simple. This is basically reflecting this guy. Select E from employee. So we display everything. That's what you actually see here. So yes, this is the case we are using JPQL, and this is the case that we are using criteria API. So you basically see same result, one from JPQL and the other one from criteria API. Okay, so let's look into the second one. So here basically we are performing the select statement with where clause. The name is Sang Shin. Okay, so here this is the difference between the first example and second example. So here we added the where clause to the criteria API. Okay, so here we have only one person. That's the reason we got just employee number 1 and Sang Shin. And third case is here we have this case. So we have a where clause where the name is Sang Shin, and then we have or, and salary is also greater than 7,000. Okay, so here we are using the criteria builder dot or, and then we have this name and then greater. So we basically add this one and then wrap this to with this or. Okay, so that's basically the same thing of this. Okay, so that is yeah. So we have two people, Bill Clinton and Sang Shin, who's so yeah. So Sang Shin is just name, and then salary. Anybody whose salary is greater than 7,000, we have Bill Clinton. He's making $8,000. Okay. All right, so the next one is here. We are just using like the pattern. Okay, so same thing you can do. So you can use like method of a criteria builder object. Okay, so here so result is this. Okay, anybody whose names start with A. So we have two people, Angela and then Annie. And next one is, yeah, so here we are basically saying the name has to be in one of these three names. Okay, so Sang Shin, Bill Clinton, and some name, and we have just two people, Bill Clinton and Sang Shin. Okay, all right, so pretty simple the uh, the uh, the examples, and you can certainly take a look at the criteria query Java documentation to find more information about how to use it. The next one is order by. So let's try order by. This one. Let's run the application. So result is, again, this is a table. And then we have, again, this is using JPQL. So here, we like to display all the employees where salary is greater than 4,000. And then we want to display the result order by. First, ename, name first, ascending order, and salary descending order. So name, you can see the name is in ascending order, and then in terms of salary, it's in descending order. Okay, and then we are going to actually do the same thing using criteria API. So same result. Okay, so let's take a look at the code. So this is based on JPQL. And here again, we just add order by the logic. Okay, so this is ascending order and this is descending order. Okay, so that's exercise 1. So let's move on to exercise the topic 2. So criteria API with relationship. So far we have worked with just a single entity and single table. Now we are going to work with multiple tables which are the related. Okay, so here you can use basically again this is the JPQL. So here what we want to do is that we like to get all the customers whose discount rate is greater than 10. Okay, so we retrieve all customers whose discount rate is bigger than 10, and discount table, discount code table, and the customer table are related. Okay, so here basically you can, I mean, this is actually very nice. You can just say customer.get and discount code and then call the get method. So it's a little bit more intuitive in using Java code. So we traverse to discount code table and get the rate. And you can also use the join the object. So here you are going to be able to use join method. Production collection is actually from the manufacturing. So this is actually manufacturer class has a product. So one manufacturer has many products, and product collection is one of the fields that represent the collection of products. And then we can create a join manufacturer and product object. And then you can call get method from this join object. Okay. So here basically retrieve all manufacturers who have products whose markups are greater than 20. Okay. So here we call p get markup and s and then change it to integer value and compare. All right, so let's do exercise 2. So here we are going to try criteria relation traversal. So that is the same code that we have seen from the example. Okay, so here, okay, so I'm not sure why this is not being displayed. You have to check the code. So here, this is using JPQL. And here we are going to use criteria API, and again, same result. Okay, so select all customers whose discount code rate is greater than whose discount rate is greater than 10%. Okay, so you can see all customers' discount rate is greater than 10. All right, so let's see the code. So again, this is JPQL example, and here we are using criteria API where we are basically chaining the traverse, the discount code table from customer. Okay. All right, so that's what we have seen. The next one is a relation inner join. So let's take a look at that. Here we go. Okay, let's run this code. Yeah, so just to show that you can actually run the same thing from Eclipse. I'm gonna try from Eclipse. So this is the code, and I'm going to run as Java application, and my package is the main class. Okay, so this is the result. So yeah, so this is using JPQL. Okay, and this is the result of using criteria API. So basically, select all manufacturers whose product collection where the markup is actually the greater than 20. Okay. All right, so I'm going to use a lab documentation to see the code. Okay, so display all manufacturers who have products whose markups are greater than 20. So here we use join the object, and again we are using the get method of markup from this the join object. Okay. All right, so moving forward, next topic is criteria API using meta model. So the reason you might want to use meta model is meta model provides a compile time type checking using generics. So as we talked about in the beginning of the presentation, the meta model, in a meta model scheme, every entity X has a corresponding meta model class X underscore. And you can manually generate this X underscore class yourself, or you can automatically generate it either using Maven or using an IDE. Both Eclipse and the NetBeans and other IDs provides a way of creating this meta model class from entity class. In our exercise, we are going to just use the Maven to generate this meta model class. And then criteria API is going to work on this meta model. So this is this is a meta model class. So again, we have employee entity class, and then you're going to have employee underscore meta model class. Again, you can generate manually, or you can generate automatically using Maven or from the IDE. So here, let's take a look at the code. So instead of using employee class, you're going to use employee underscore meta model class. Okay. So idea is that this meta model class of name should be string type. So if you actually provide like an integer value, then it should actually generate a compile error. So this is a case that you are not using the meta model, and this is a case that you're using meta model. So when you're not using meta model, you still actually deal with a string, right? So this string does not actually provide a compile time error, but if you're using this class, it will actually provide a compile time type checking errors. Okay, so again, usage of meta model enables you to do type checking during compile time rather than runtime. So this is the corresponding employee meta model class. Okay, so here, employee underscore, and you can see it has employee integer type, and this one has to be string type, and this one type has to be long type. Okay, so salary has to be long type, and name has to be string type, and ID has to be integer type. All right, so let's do criteria API with a meta model. So what we are going to do is we are going to actually try manual meta model generation first. So here what we have is that we have generated, if you take a look at this one, we manually generated employee underscore meta model class ourselves. Okay, so meaning you manually code this code. It's not that difficult for simple class like that, but for complex class, then you might want to actually have IDE or Maven to generate. Here is pretty simple, so we actually created ourselves. Okay. Now, when we run the code, let's see what happens. So basically, it performs pretty similar uh, uh, the query operation. So this is uh, select JPQL, and this is using the oh, okay, looks like I'm not sure. Okay, so something is missing here. I was actually playing around with the code. So I'll take a look at that. And this one is again using JPQL, and this is using again criteria API, now using meta model. And so that's an example. So let's take a look at the code. So this is the employee underscore meta model class that we manually, wrote, and then you're gonna import that class, okay? And then instead of, so this is the case that you are not using a meta model. So you say employee.get and name. So you are using still string, okay? But using meta model, you are basically using meta model class, okay? Here, like this, and provide this value, okay? So again, the example shows this is a case that you're using the criteria API, not using meta model, and this is a case that you're using meta model. Okay, so as far as the code is concerned, it's pretty similar. Okay, you're just basically using this meta model class. All right, so now let's take a look at the case that we are going to automatically generate that meta model class. So I'm going to actually, for now, I already generate, so that's the reason there is no compiler. So I'm going to just clean, okay? And you'll see this compiler because we don't have, so if you take a look at this code, we have a compiler because we don't have this class yet, okay? Because we have not created employee underscore meta class ourselves, okay? So here what we are going to do is we are going to use Maven. So if you take a look at I'm going to actually show you Maven code that you can actually add. So if you add this plugin to your Maven, the pom.xml file, then it will generate a meta class, meta model class for you. So we are going to actually now rebuild it, and then it's going to generate I'm going to, let's try clean build or build. Okay, now we have generated code. So here you can see we have employee underscore code has been generated here. Okay, and now we do not have compilers. Okay, and when you run the code, it should work exactly the same. Okay. All right, so yeah, so I think my previous code, I play around, so that's the reason you don't actually see this result. Okay. Okay, so that is meta model. So moving forward. So we covered criteria API. Let's move on to locking. So JPA 1.0 supports only optimistic locking, and JPA 2.0 as pessimistic locking. And so if you take a look at lock mode in JPA 2.0, it could be none, it could be optimistic, it could be optimistic force increment, it could be pessimistic or pessimistic force increment. In JPA 1.0, you use, in fact, the read and write. This read and write are same thing as optimistic and optimistic force increment, same thing. Okay, it's recommended that you use this value from moving forward, but you can still use read and write. Okay, so we're going to mostly focus on optimistic locking and pessimistic locking. So while locking, it's basically to maintain consistency of the data because there are multiple users trying to read and update at the same time, and you do not want those users to intermix each other, causing inconsistency of the data. So from the semantics standpoint, basically locking should prevent dirty read problem and non-repeatable read problem. Okay, so let's take a look at what it means. What dirty read means. Dirty read problem occurs when two clients, so client one start the transaction, and then client one add a record, and then client 2 see this change right away. So this is a dirty read because at this point, client 1 can still roll back, okay? And then client 2 doesn't see it. So this is considered a dirty read because it's not really real data, but it's actually something that was inserted by the other client but has not been committed, okay? So this is the dirty read. Non-repeatable read problem is like this. So client 1 start the transaction and insert a record. And so until it commits, until client 1 commits, it doesn't see it. But once client 1 commits it, then client 2 sees it. So it is non-repeatable read because when repeatable read is performed in a single transaction, you see different data. Okay, so here, the read does not, so here, read is not, the record A is not available, but after client 1 commit, the same in the same transaction, client 2 sees it. So it's non-repeatable read, meaning, in a transaction, what you want to do is that you want to read multiple times and you should actually get the same value, right, within a single transaction. Okay, but in this case, it is non-repeatable read because a client 2 sees a different data in a single transaction. So this dirty read and non-repeatable read, these are the things that need to be addressed through locking. So let's take a look at optimistic locking versus pessimistic locking. So in optimistic locking, it's assumed that entity has a version attribute. The table should have the version attribute is actually annotated with the @version annotation, and that field has a corresponding column in a table called the version. Okay, and whenever an update is done, the version number gets incremented. Okay, so this is a way that to find out whether there is actually collision or not is going to be addressed. We'll actually play around with that concept in a few seconds. In optimistic locking is very short because the client just locked the record only during read, and once it's read it can change it, but at that point, once read is done, the locking is released, which means that other client can actually access data and change it. Okay, so let me just read this one and explain one more time. Locking period is short compared to pessimistic locking. Pessimistic locking, it will actually lock the whole period. Okay, but here hold the lock only when transaction reads, and it releases the lock when read is done. So no lock is held while changing things, while changing that entity in memory. So it provides a higher performance because there are multiple clients can actually access the data more frequently, but it provides a less isolation. So once the client 1 reads the data, and then the client 1 changes the data, and in the meantime, before the client 1 commits it, if there is a second client actually change the data, then that's where the optimistic exception occurs when the first client tried to commit. Okay, so when the first client see the optimistic exception, then client will actually reread it and change it and commit it again. So that is the sequence that client 1 has to deal with. So we're going to actually play around in a second. It's actually recommended. I mean, in fact, the optimistic locking is the default in most cases because it provides the higher performance, with reasonable isolation, and it's recommended for many reads and occasional write and update. Okay, so that's optimistic locking. Pessimistic locking is that locking period is long, so it holds the lock until commit is done. Okay, so it provides higher level isolation, but it certainly provides a less performing the application, and it's actually recommended only when there are frequent updates and delete on the table. Oops. not sure what happened. Hold a second. Okay, yeah. Sorry about that. All right. However, the optimistic locking is used only when the version field is available on the entity, and also table also has the version column. However, pessimistic locking can be used, for entity that does not have a version attribute, okay, and which means that there is no version column in the table. Uh, Optimistic locking modes could be optimistic and optimistic force increment. So optimistic case, it locks the entity when the transaction reads it for entities with a version. And this one, it's going to, even if you are just reading it, it will actually increment the version count. Right? So before we move on pessimistic, I'm going to actually demonstrate the exercise. I'm going to actually, let's do the exercise. So we're going to actually try the versioning. So we're going to actually see how the version number gets incremented for optimistic case and optimistic for increment case. Okay. So let's try to run that application. Optimistic version. Okay. So let me just show the code. So let me show the model first. So we have employee entity class, which has a version field and is annotated with a version. Okay. Table N also has a version, the column. Okay. And now if you take a look at this code, so basically what we are trying to do is we are going to create three employee records, Sang Shin and Bill Clinton and Angela. And then you're going to actually play around with the transaction. So here we are going to find the first employee. So in this case, first employee should be Sang Shin. And then we are going to change that employee. We are going to actually increase the salary of Sang Shin by 300, and then we commit. Okay, so every time a change is made, the version number should be incremented by 1. So when the record is created, the version number start from 1. So after this, the Sang Shin's version should be incremented by 1, so which means that version number should be 2. Now, in this case, when you are using just the optimistic locking mode, and here we are going to just find operation, meaning we are not performing any update, okay? In this case, the version count does not get incremented, okay? But if you're using optimistic force increment, then even for read, it will increment it. So let's run this application. In this case, what we are going to see is the version count for Sang Shin, it should be 2. Okay, so as you can see, the version count is 2. Okay, so if we actually have another one, if you actually perform another update operation, then it will increment by one more time. So let me just try this. Okay, so we'll just change it to 400. Okay. So right now it's 300, then it should actually increment to, the 10,700, something like that. So in this case, it should increment to 3, as you can see here. Okay. Now, optimistic force, this is the case. Let's take a look at this code. This is exactly the same code, but here we are using optimistic force increments. So in this case, even if you are just reading it, it's going to increment. So in this case, it will actually see 3. Okay, so let's run this code. Okay, so as you can see, it's 3. Okay, and if you try this one more time, then it will become 4. Okay, so it becomes 4. All right. So that is how the version value gets incremented each time the change has been made. That's the case when optimistic, and the optimistic force increment is that regardless whether that's a read or write, it will increment it. Okay. Now, what we're going to do next is we are going to actually experiment optimistic locking exceptions. So we are going to actually try two clients. So here we have optimistic locking user number one, and then we have optimistic locking user number two. So let's take a look at this number one code. So here what we're going to do is, again, we created three employees. And then what you want to do is we are going to just open this JOption pane. Here we are going to ask a user to enter some value for updating this record number one, Sang Shin. Okay. What you're going to do is, however, once we got this JOption pane is up and running, then we're going to go to the the second client, and then we're going to update it. So what happens is this. Once you got, so let's run this application first. I'm going to just run it. So it created three records, and then it should have the dialog box. So at this point, we have read the version count of employee one. That should be one at this point. Now we are going to actually run the second user code. We're going to actually run the second client. The second client is going to change the value of employee one, same employee one that this client one is actually trying to change. Okay, so when we run this one, Sang Shin's version count now should be 2. Okay, so let's run this guy. Run. So you can see the version count incremented 2. So when the client 1 is now trying to change the value, it figures, the version count that I have is 1, but the version count is incremented to 2, which means that somebody has changed it, right? So this is a case that we are going to experience optimistic locking exception for this user. So let's try it. And then if you take a look at this user number 1, you're going to see is optimistic locking exception. So here, optimistic lock exception, and because the other user has changed it, meaning version number has been incremented. So in optimistic locking, the version field is used to detect if there has been some collision or not. Okay, so this is optimistic locking. All right, so let's move on to pessimistic locking. So pessimistic locking is pessimistic, meaning it holds the lock for a long time, which means that there will be less number of users that can actually access the data. So it would certainly provide less performing application than optimistic locking. That's the reason, in fact, most applications want to use optimistic locking as a default. But there might be some cases that you might want to use a pessimistic locking, especially when there is a possibility of deadlock or possibility of a lot of changes by a lot of clients. So in fact, you are serializing the change to the application. So until the first transaction finish the update, the second update by the second client cannot get started. Okay. So the second client has to wait until log is available, meaning until the first client releases the log. Okay. All right, so pessimistic read, there are pessimistic read and pessimistic write and pessimistic force increment, okay? 3 different types. So pessimistic read is that entity manager logs the entity as soon as transaction reads it, and then log is held until transaction completes. And this lock mode is used when you want to query data using what is called the repeatable read semantics, meaning so repeatable read semantics is the semantics that solve the problem of non-repeatable read that we talked about, okay? Which means that once you set your the locking mode to pessimistic read, you do not want anybody to change it, okay? Because you do not want to have a non-repeatable read problem, meaning when you read the second time or third time, you want to actually receive the same data. And one way to solve it is preventing anybody else to change. Okay, so in other words, you want to ensure that data is not updated between successful read this lock mode does not block other transactions from reading the data. So as long as other clients can read the data, that's fine. But the updating is not allowed. Okay. Pessimistic write is locks the entry as soon as a transaction updates it, and this lock mode forces serialization among transactions obtaining to update the entity data. This is the case that you do not even allow the other clients to read. Okay, so compared to pessimistic read, here you allow other clients to read. Pessimistic write, you do not even allow the read. Okay. And the pessimistic force increment is the same thing as a pessimistic write, but you're going to increment the version attribute of the version entities. If the version if the entities doesn't support version field, then this is a moot point. That's the same thing as a pessimistic write. But if there is a version field, then version value will be incremented. So the way that you can specify this locking in JPA code is that you can use in entity manager method such as lock, find, refresh, or you can use query object, the query.set lock mode, or you can use a type query set lock mode. Okay, we're going to play around mostly with the entity manager method. All right, so let's do exercise 4. Yeah, so we did optimistic locking. And we're going to actually try the pessimistic locking. So pessimistic locking, we're going to actually try again 2 users. So, user number 1, so client number 1 and client number 2. And the first user, let's take a look at the first user code. Okay, so here, this is the first user. What we want to do is we are setting the locking mode to pessimistic read. Okay, so what it means is that locking is held by this client until commit is done. So it could be actually very long holding of the lock. Okay, so until this commit is done, other client cannot change it. Okay, so this is the other client. So other client is trying to change the value, and because the other client, so here again we are going to actually have this J option pane being displayed. So until we finish this one, this client 1 will actually hold the lock. And when second user is trying to update it, it is going to wait for the lock from the client 1 to be released. And eventually, this second user will actually experience this error. SQL transaction rollback and lock cannot be obtained within the time it requested. Okay, so that's the exercise we're going to actually try. So let's try optimistic locking. Not optimistic locking, pessimistic locking. Pessimistic locking, user 1. Run. And we're going to actually see this, the dialog. So now the client 1 holds the lock. Nobody can actually take the lock away. So we're going to actually go to the second user. So if you again take a look at the second user, this user is trying to change. Is trying to update the salary of employee 1. Okay, so obviously he has to have a lock. Okay, but because the first user holding the lock, this user will actually time out. We'll get the exception. So let's run the second user. Yeah, so the it waits about 10 seconds, and then it will have an exception indicating it cannot get a lock. There is a way that you can set the timeout at the entity manager or entity manager factory level, or even actually for the whole application using changing persistent unit XML file. Okay, so there are 3 different ways that you can set the lock waiting expiration timeout. So here we are using default timeout, which is going to be actually more than 10 seconds. Looks like it's almost 20 seconds. And after this, we are going, yeah, so here we go. So here, it says SQL transaction rollback exception, meaning it's going to roll back because, lock cannot be obtained within the time specified. Okay. Now, what we're going to do is, let's see whether we can actually just read. Okay. So in this case, we are going to just comment out the second user. Okay. So again, the first user still holds it because we haven't changed anything. And, we haven't actually played around with this client. So client one still holds the log for this particular employee number one. Okay. But we're going to just read it. Okay. So in this case, we're going to just, we're going to just read it. Okay. So, all right. So second user can actually read the data fine because this is a read operation. Okay. But if you try to write something, then the log is required, and then it will time out because it couldn't get the log. Okay. All right. So that's pretty much what I have. Let me just make sure the